Okay, so this is going over questions. This is a review sheet from the derivative review, going over question number two, B, E, and F. Okay, so question number 2B, if we take a look at limit as x goes to infinity, this is endpoint behavior, so we can use our strong over weak argument. This is a power, okay, the highest power would end up being 3 over 2. This is log. This is strong over weak. Okay, so this means that we know that this goes to infinity. We don't really need to apply L'Hopital's here, although we could. So this would have been an infinity over infinity. So you could use L'Hopital's here. Here again, we have a log function. So we have an infinity function that we can just actually evaluate this because we know that cosine of infinity has to be between -1 and 1, and we know the log becomes infinite. Okay, so we get some finite number over infinite, which means it's going to be equal to 0. Again, if you want, you could apply L'Hopital's here, okay, because we would end up being, actually cannot apply L'Hopital's here because we would not get an infinity over infinity form here. Okay, so we have finite number infinity, so we end up with it equal to 0. Here we have the limit as x goes to 0, and this would have to go from, no, it's going to 0 from 1. Okay, so we know that it's going to be log 1. Okay, log 1 is 0, and this is going to be cosine of 0, which is 1. So we end up with 0 over 0. This one we would need to use L'Hopital's because there's no real algebraic way to get rid of that. So using L'Hopital's, I end up with the limit as x goes to 0, and this derivative becomes positive sine 4x times 4, chain rule, and this becomes 1 over 1 minus x times -1. Okay, so we end up substituting in, we end up with 0 over -1, which is 0.